Okay, let me do problem 6.1 from the book Marketing Age. What is the age distribution of promotion sensitive shoppers? A supermarket super shopper is defined as a shopper for whom at least 70% of the items purchased were on sale or purchased with a coupon. This is defining what a super shopper is. The following table is based on information from trends in the United States. So it tells us for some given age range, like 18 to 28, that we have 7% of the super shoppers, and so on. For the other age ranges, what percent are of the super shoppers are in that age category? Let's look at these problems now. So in A, erase that. A, forget some of the terminology. Let's just look at the let's make a probability distribution out of this. So we have some outcome possible. Whenever you're looking at a probability distribution, we're thinking of some possible outcomes. So the outcome is you're picking a shopper at random, and what's the chance of the shopper being between ages 18 and 28? Well, it says the probability of that. So for each outcome, we get a probability. We get a probability there of 7%, which usually we write as, well, let's write as 7%. Usually write this as 0.07 using decimals. Then we have this category, 29 to 39. There we have 44% of the shoppers, and so on down the line. I'm just copying the table, so dot, 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 I'm just copying the table. So the question, do we have a valid probability distribution? To be valid, the issues are, well, one, all the probabilities should be 0 or bigger. They can't be negative. You can't have a negative chance of something happening, so 0 or bigger, and check, they are all, so one is they're all bigger than or equal to 0. Check. Second thing to check is, do the probabilities sum to 1? So they need to sum to 1. Or using percentages like this, or in this case, needs to sum to 100%. But one of the things has to happen so it should sum to 100%. Well, let's check. What is 7% plus 44 plus 24 plus 14 plus 11? Let's see. I'll do this in my head. 7, let's see, 7 plus 44, that is 51. Add this in, we get 75, and put in that, so it's going to be the one being 25, gives us 100. So check. Do you get 100? So in fact, the answer is yes, this is a valid probability distribution in A. That's A. What I really needed to do is check those two properties right there. Let's see for B. So let's use a histogram to graph the probability distribution. This is a really nice way to visualize probability distributions. So what you do in this case is, let me put this, I'll put B right here. So you draw along your horizontal or x-axis the possible outcomes. So I'll put here the outcomes. The outcomes are, well, one is you could pick a random shopper. The shopper might be between 18 to 28. That's one outcome. Another is they're between 29, and 39. I'm going to run out of room here. Let me see. Next, 40 to 50, then 51 to 61, and finally 62 and over. So I got my outcomes along the horizontal, and along the vertical, put the probability of each outcome happening, put it as in a histogram, put it as a bar above that. So for 18 to 28, we have 7%. Let me put labels along here. I'll put this as percentages. That's 10%, 20%, say 30%, 40%. And I'll put a rough bar there. So, but this one, I'll put 7%, so I go up there. 29 to 39, it's a 44%, so I go like up here to about a little over 40, so that's like that percent. 40 to 50 is 24%, so let's go up to about there. 51 to 60, that's at 14%, so go up to about there. And 62 and over is at about 11%, so say about there. So B is a really nice way to visualize a probability distribution. You sort of can see the bars like that, okay? So we talk about representing a probability distribution by histogram. We mean this thing in part B. Now what about finally C? I'll squeeze over here. Compute the expected age of a shopper. So recall expectation is evaluated by multiplying the value times the probability of getting that value. Now for here, what I will do is, since that number is not really a value, so another way you could do it, this is why they say to use in part A, use the age midpoint. So I could have, in this part, let me change it to do that. Rather than 18 to 28, I'll put the midpoint, 23, just to represent that value. And so on for each one of these. I can replace the range by a midpoint. This is useful for finding the expected value, and so on. I can replace those. So let's find expectation, where now I'm going to use these midpoints right there. So there's a 7% chance of getting a 23, a 44% chance of getting a 34, and so on. So the way you do expectation is you do, well, 7% times 23 plus 44% times 34 plus 24% times 45 plus 14% times 56, finally plus 11% times 67. At this point, I should have a calculator ready. Let me, I don't, so doing it in a calculator, the first one would be 7% is a decimal. It's easy to use decimals in a calculator. It's 0.07 times 23, put that in your calculator, you get something, plus, next one's 44%, that's 0.44 times 34, and so on. Add it up, put it in your calculator, you get some number, whatever you get, that's your expectation. So for your work, Just plug in that number into a calculator, find out what it is, and you get your expectation. Okay.